Graphing logarithmic functions. In this lesson, we're going to take a look at the graph of a logarithmic function, and we're going to compare it to the graph of an exponential function, which we saw in our first lesson for this chapter. So, we're going to compare y equals 2 to the x to y equals log base 2 of x. Now, as we mentioned in class, these are inverse functions of each other, because you can see here that the 2 is the base of both, and you can see how if we're switching the x and the y to make it inverse, that we'd be taking this 2 raised to that y power to equal that x, but then switch the x and the y and you get this. Okay? Alright, so going back to our exponential function, if we're graphing y equals 2 to the x, we get this table. This is the same table that we used in 4.1. But now, using the fact that excuse me, these are inverses of each other, the table for y equals log base 2 of x is going to have all of the x and y values here reversed. So here, my x was a negative 2 and I got a 1/4 for y. Here, I now have 1/4 for x with negative 2 for y. Notice here, when I have 0 for x, I get 1 for y, whereas here, 1 is now the x and 0 is the y. And so on. You can see in each case that the x and the y values just get switched. So when we actually go to graph this, this is what we said y equals 2 to the x looked like. Okay, you can see that exponential growth that we talked about. But now if I take each of those points from the table that we just established for y equals log base 2 of x, you can see now the way that this is going to curve. And if we fit a smooth curve to this, our graph is going to look like this. Now, if you remember in previous classes when we've talked about inverse functions, not only could we identify an inverse function by switching the x and y around, but we could also identify it graphically by whether it reflected through the y equals x axis or line. So this purple dotted line is our y equals x line. And I think it's pretty safe to assume that this curve, if we reflect it through this y equals x line, is going to give us that curve. So when we switch the x and the y values together, what we get for one graph gets reflected through y equals x and gives us our other graph. And this graph now is our y equals log base 2 of x. So now take a look at this. Notice some of the features here. Before, with the exponential, we had a horizontal asymptote that we could not cross. But now, we have a vertical asymptote that we cannot cross. Okay, so now our graph is coming in here closer and closer and closer to this vertical asymptote, but we never seem to cross that. Also notice that the key points got switched. Before in the exponential we said one of the key points was 0, 1, because if you put 0 in for x as the exponent, anything to the 0 power always gives you 1. Well, because we are talking about an inverse function here, the key point on your logarithmic function is going to be just the reverse of that. So now the key point is at 1, 0. Because if we put 1 in for x, remember we said in class the log of 1 is always 0. Okay? And then probably the easiest way to actually do some of the graphing is to actually think about your exponent. Think about what your XY table would be in the exponential form, and then switch them around to end up with your logarithmic form. We'll talk more about that in class, but that's kind of how you want to think of these. Now, if we actually analyze a logarithmic function real quick, again, we're going to do this in comparison to the exponential. So in the exponential of 2 to the x, we have a domain that's all real numbers, and we have a range of 0 to infinity. Okay, well, because of that switch that we've made, now the domain and the range switch. Since x and y values switch, domain and range will switch. So now it's actually my domain that's being limited, and my range, which is unlimited. It can go up and down as far as I can imagine. Okay, excuse me. So now for the logarithmic, it's my domain that will go from 0 to infinity, and my range will be all real numbers. Okay, now for the intercepts, remember we had no x-intercepts, but a y-intercept at 1 when we were talking about the exponential. But now, because we flip-flop that, now we have an x-intercept on the logarithm and no y-intercept. So now the x-intercept is at 1 and the y-intercept is none. Now the one thing that does stay the same is the fact that our graph is always increasing. Whoops, sorry, that's the wrong way. So when we start on any point down here, if we move to the right with x values, our graph is always going up. It kind of slows down as to how much it's going up here, but it is always going up. So we are always talking about an increasing function. So this is still increasing, but the difference is that we're not increasing from negative infinity to infinity, we're just increasing from 0 to infinity. Because again, we are limited as to which x values we can use based on the domain. We still do not have any max or min points, and we still do not have any symmetry. So those remain the same, just like the exponential. Now, again, because we have switched these things around, what was the horizontal asymptote at y equals 0 on the exponential function, that horizontal has now become this vertical. Okay, so instead of a horizontal asymptote, we now have a vertical asymptote, which is the x equals 0. Okay, and then as x approaches negative infinity, that one does not apply. That's not applicable because x doesn't go to negative infinity. Next, x can only get as low as 0. So that one is not applicable, but as x gets bigger, goes towards infinity, then our f of x also will go toward infinity. Okay, so you can see in a lot of cases what happens with our logarithmic function in terms of our function analysis has to do with the fact that we can take our exponential function and then just switch x and y's. So domain and range get switched, the x and y intercepts get switched, and our asymptotes get switched. What was horizontal becomes vertical. So if you can keep this relationship in mind, then it can make graphing a whole lot easier. And that's what we're going to do in class. We're actually going to look at how we can graph different logarithmic functions with different bases using its comparison to the exponential and using transformations as we've done with other functions. So that's what we'll be looking forward to in next class, and we'll see you then.